A finite geometric series problem where the terms themselves are pretty wild irrational numbers, I guess quadratic, cubic. Now, I'm just writing down kind of the usual. This is very familiar stuff right here. First term is a sub 1. The next term is a sub 1 times what we call the common ratio. I'll tell you more about that in just a second. And then right here, this would be a sub 1 r squared and so on. Like that. Okay. So it's 1 less. The index of the term is 1 more than the power. Okay. Now in this particular case, the common ratio, this is called the common ratio R. R is the ratio of two pretty wild irrational numbers. Not that common an appearance in this sort of problem, I don't think. But so the fourth root of 6 is actually a smaller number. That's because 6 cubed is less than 5 to the 4th, actually. But we don't have to worry about that right now or ever in this problem, I don't think. But so R is actually the fourth root of 6, which is the second term in our geometric series, and divided by the cube root of 5. So in this case, this is what this is equal to R2 divided by R1. But all the terms in succession form this ratio, okay? This common ratio. So R3 divided by R2 would let's see here. Oops, sorry. That should be A2 divided by A1. So this is A sub 2 divided by A sub 1. And it's called the common ratio because all the way down the line, like the next, this would also be equal to A sub 3 divided by A sub 2 all the way out, okay? But in any event, these are our assignments here for this problem. We're supposed to evaluate this strange, it's a year problem, 2024. So let's see what we can do with this based on what we've written down so far. Now this statement right here is just essentially what I've written down up here, okay? And so what we can do right here is just recopy this based on this result. And I've done it here for you just to save some time. And you can see exactly how this result applies. Sometimes you have to do this in a repeated fashion. But notice that a sub 13 is a sub 1 multiplied by r 12 times. Okay, 12 r to the 12th. And similarly for a to the 2036, that would be a to the 2024 times r to the 12th also. Okay, now what the nice thing that happens about this problem, the way it's designed, is you get a factored circumstance where you get some nice cancellation. And so this would be equal to 1 over r to the 12th. I'm sure a lot of you are starting to see how this works out nicely. This would be equal to, and that's off the screen right now, but this would be equal to 1 over, and let me just put all of this, we're going to have a big expression raised to the 12th power, and it's going to be a quotient. Okay, so raised to the 12th power. And let's remember what what r is. Okay, r is equal to the fourth root of 6 over the cube root of 5. Okay, so we have the fourth root of 6 over the cube root of 5. So right here you would have the fourth root of 6. Now it's useful to think of this as 6 to the 1/4. And what's the other one? Third root of 5. Third root of 5 right here. And again, folks, the slightly more convenient notation probably is thinking of this as 5 to the 1/3, 6 to the 1/4. But in any event, what's going to happen right here, this will be equal to 1 over, okay, 6 to the 1/4 raised to the 12th power is 6 cubed. Okay, so you would have 6 cubed right here. And also right here, 5 to the 1/3 raised to the 12th power would be 5 to the 4th. Okay. Okay, 5 raised to the 4th power. Okay, so folks, if you invert and multiply, let me just come down a little bit lower here. If you invert and multiply, you actually get, can we do 5 to the 4th in our heads, 625? So we get 625 divided by 216. Okay, which final answer? 625 divided by 216. I like the problem quite a bit, folks, because it was made up in the sense that you had this convenient 12th power going on, which has a way of wiping out these rational exponent forms here, 1/3, see, and then 6 to the 1/4. So you see, it was actually, like so many competition problems, these problems are designed to work. By the way, this came from the Carnegie Mellon Informatics Math Competition held in 2019. This gentleman, I can't pronounce it, sorry, but he designed this problem. And I made up some different constants in a different year. His was a different year, maybe 2019, I guess. But in any event, we finished the problem off. Hopefully that made quite a bit of sense. Fairly easy problem if you're familiar with finite geometric series and the relationships between the terms. It's really some pretty direct algebra. The part that maybe look a little wild here is you have the 3rd root of 5 and the 4th root of 6. Those aren't, usually it's nicer numbers like 1/2 or 2/3 or something, But these are, I call them, this is a cubic irrational number, a quartic irrational number. And we know that by form, this ratio is the common ratio without really knowing what this object looks like. We could make some progress simplifying this, I guess, but we never really have to, which is a cool thing. But we do know that this evaluates to a nice rational number, namely 625 over 216, a number that's a little shy of 3, right? 3 times 216 would be what? 648. So this number's pretty close to 3, all right? But in any event, that's the solution. Thanks for viewing.